Alright, hey, how's it going? Nick here. Playing around with my PIC MPLAB widget. We have analog input wired up right now, so let's take a look at that. Alright, so this is pretty boilerplate code here. So AD init basically conditions the AD subsystem initially to allow input on channel 0, left justified output. Not a whole lot going on there. We set up port B to be an output port, just to let us see what the AD value is that we're reading in, and then our main loop just calls this read AD function, moves the W register out to port B, and just does an infinite loop. The reading is pretty straightforward, but we first check the most significant bit of port A, so we mask it with 80 hex to pull off that top bit, and if it's 0 we go down here to read AN0, otherwise we're reading analog channel 1. So RA7 lets us choose which analog channel we're reading from. If it's set, then we turn on this bit in ADCON 0, which says we're going to read analog 1, so that actually selects analog 1. Otherwise we go ahead and we clear that bit, and that'll select analog 0. And then our main AD operation, just turn on the go bit, loop waiting for the go bit to be clear. That means it's done. Copy the result register into W and return. So that's our straightforward code. Let's go ahead and build this, and then let's go ahead and run it in the simulation. Alright, so here's our widget running right now. I haven't loaded a file in, but by default, you know, all the pins are input pins, and these 7 pins in particular are analog inputs, so we have analog sliders on here that we can use to set those analog voltages. But let's go ahead and load in that hex file that we just made. So we'll pull that in, and the code is running right now, and it's looping, you know, in the beginning of the code. Basically port B turned into output, so those inputs are disabled. All of port A is an input except RA0 and 1. Those are still inputs, but they're analog inputs. And remember, the code by default is reading analog channel 0 and displaying the voltage on port B. So as I move this slider, I'll start to see that output voltage. Here I am at 2.5 volts, and you can see that I've got, you know, a value of 128, 129. And we can come all the way up here to 5 volts, and there's, you know, the full value, and so on and so forth. AN1 is being ignored, but if I turn on bit RA7, the code says let's read AN1 and copy that to port B instead of AN0, so now I can use this slider. So, you know, nothing significant about this particular code, except that it's just an example of using analog input with this widget along with digital inputs and digital outputs. So so that's my workbench for now. Gonna play around with pulse width modulation next. Alright, take care. Bye.